Good morning, friends. Welcome back to my channel, Coding Environment. In today's video, we will solve another linked list problem which says that we have to return the intersection point of two linked lists. So here you can see we have been given the head of two linked lists, head1 and head2, and these two linked list is getting intersected at this point, right? So you can see it, the first linked list a1 a2 c1 c2 c3 is the first linked list, and the second linked list is the b1 b2 b3 c1 c2 c3, and these two linked list is getting intersected at this point where it is c1, right? So in this case we have to return c1. Similarly, if you see this two linked list, in this linked list, both the linked list is not intersecting at any point. So in this case, we have to return as a null. So you got the problem statement, right? If there is an intersection point between those two linked lists, we have to return that intersection point. And if there is no intersection, we have to return it as a null. So how we can solve this problem? So there are multiple approaches to solve this problem, and we are going to see all those approaches in this video. Now let's go with the approach 1. So in this, what we will do is we will compare each node by traversing one list at a time. Now just assume that we are going to traversing on the second list. So we will traverse the list B1, B2, C1, C2 and C3, right? So this is my linked list 2. So just assume that I am going to traverse on this linked list, and what I will be doing, I will be keep on comparing the node of the other list. So just let me write the other list also here, so you can see it like A1, A2, and this is also C1, C2 and C3. So what we will be doing is like we will be keep on traversing the first list and then keep on comparing the node from the other list. So what we will be doing is we will be comparing, right? So we will compare B1 with A1, which is not equal. Again, we will compare B2. We will move one node in the list 2, and we will compare B2 with A1, which is not equal. Again, C1 to A1, which is not equal, and C2 to A1, which is again not equal, and C3 to A1, which is again not equal. So what we'll do, again we'll come back to B1 and then compare the other node from the second linked list. So in this, we will compare B1 with A2, which is not equal, B2 with A2, which is not equal, and C1 with A2, which is not equal, C2 with A2, which is again not equal, and C3 with A2, which is again not equal. Okay, and again we will move to the next pointer here, right? So now we will compare C1 with C1. So from A2 we will move to C1, and now we will compare C1 with C1, which is equal, right? So which is equal, and we will return this C1 in this case. So this is very simple approach. We will keep on traversing one linked list and pick one node from the other linked list and compare that node with my traversing linked list. And if there is any linked list we will find which is equal, we will return that linked list as like intersection point. So this is one approach, but the problem with this approach is like time complexity. It will be of, if this is the length of m and this is of the length n, the time complexity of this approach will be m cross n, which is of course not equal. So how we can optimize this approach? So the second approach, if I will say, in this second approach, let me again write the linked list. So we have B1, B2, C1, C2 and C3, and we have one A1, A2, C1, C2, C3, right? So in this second approach, we will first traverse the linked list 1 and linked list 2, and we will keep the node of one linked list into one hash set. Okay, so just assume that I'm going to traverse on this linked list L1, which is denoting B1. So I will keep one hash set, and then I'll keep on adding all the node from my first list. So I will add B1, B2, C1, C2 and C3. Okay, so this will be my hash set, and after that I will be traversing the linked list 2 and keep on comparing each node from my list 2 in this hash set. So when I'm traversing A1, I will check that the A1 is present in this linked list or not. So A1 is not present, right? So we'll just move to our next node of that linked list, which is A2. Again, we will check that the A2 is present or not. If A2 is not present, we can see it. Then we will move to the C1, and then we can see that C1 is present here, right? So in this case, we will return C1 as our result. Okay, so if you see this approach, here the time complexity is just m plus n, because we are traversing this linked list one time and this linked list another time, right? So the time complexity will be m cross n, but the space complexity will be somewhat m or n depending on which linked list we are storing into our hash set. So in this approach, we are going to consume some extra memory, which can be also optimized in the other approach. So this is the 2 approach. Let's move to the approach 3. So to explain this 2-pointer approach, let me again create that 2 linked list. So here we will have B1, B2, B3, and we will have C1 and C2. And for making it like 2 different length of the linked list in my A1 and A2. So here you can see in my linked list 2, I have only 4 nodes here. So it will be connected something like this. So if you see this linked list 2 length is equal to 4, whereas the linked list 1 length is equal to 5, right? So what we're going to do in this 2-pointer approach. So in this 2-pointer approach, we will initialize 2 pointers, pointer 1 and pointer 2, okay? Where my pointer 1 will be pointing to the head of my this B1, and pointer 2 will be pointing to head of my this A1, okay? So it is like my pointer 1 and pointer 2 will be pointing to the head of the 2 linked list. After this, we will compare each node simultaneously. So you can see in this case, what we will do, we will compare our B1 with A1. Again, compare B2 with A2 and compare B3 with C1. So we'll keep on doing this unless and until my pointer 1 is not equal to my pointer 2. So if this is happening, if my pointer 1 is equal to pointer 2, it says that we found that intersection, right? We found the intersection. But if it is not pointing, if it is not equal to, so we'll keep on moving our pointers. We'll keep on moving our pointers. So pointer 1 will be now nothing but the pointer 1 dot next. Similarly, my pointer 2 will be nothing but my pointer 2 dot next. Okay. So what we are going to do, we will first compare B1 with A1. Again, we will compare B2 with A2. Okay, so see here, we are comparing this pointer 1 with pointer 2, and if it is not equal, we will move our pointers 1 node ahead. Okay, so we will do this only. So what we are doing, we are making our pointer 1 is equal to pointer 2. If this is true, we are saying that we found that pointer, else we'll keep on moving our pointers. So there will be one condition at last, like my pointer 1 will point to the null if it is not finding any intersection, right? And also my A1 can go and reach till null. So in that condition, if it has not found any one of this condition, it means if it has not found like pointer 1 is equal to pointer 2. So if my pointer 1 is equal to null, which means my this means this pointer 1 is reached till null here, then what I will do, I will make my pointer 1 to point to head 2, which is nothing but the node to head node. Okay. And similarly, if my pointer 2 is reaching to null, I will make my pointer 2 to point to head 1. Okay. So in this case, if pointer 2 is reaching till null, we will make this pointer 2 to point to head 1. Similarly, if the pointer 1 is reaching till null, we will make this pointer 1 to point to head. Okay. So this is very simple approach, right? And if we have found this, then you just return this pointer 1. Okay.